Alright, so quiz review or test review. So, just to kind of recap just a little bit of every type of question so that you have the confidence to do this. There's my pen. Alright, so the first thing I said is that you should definitely be able to do two questions similar to this, where you're classifying a triangle by sides and angles. Make sure you could do both. Don't just do one or you'll get it wrong. So the triangle I was given had sides 7, 7, and 10. So the first part's super easy. I see that, hey, this and this are the exact same number. And anytime they have two of the exact same numbers, I know that has to be classified by the sides as isosceles. There's two S's, two are the same. Had this been like 6, 7, 10, we would have said scalene, or had it been 7, 7, 7, then I would know that it was equilateral. But since there's only two, we're going to say isosceles. The part that people forget is that, hey, you still need to classify this by angles. So I would go up here and say, okay, well, I need to make this A, B, and C. C has to be the biggest one. That's really it. The other one doesn't matter what you pick, as long as you make C the biggest. And then you come over here and you say, well, C squared has some relationship that I don't know to A squared plus B squared. And we want to figure out what relationship has to go there. So I'm going to plug this stuff in. I'm going to take this A and plug it in here for 7 squared. Take this B and plug it in, and I've got plus 7 squared. Leave this blank spot and put the 10 over here for 10 squared. 10 squared will give me 100. Leave my blank spot. 7 squared is 49 plus 7 squared, which is 49. And then I can look at that. You may want to go one more step further and say, okay, well, this is 98 and this is 100. So is 100 greater than 98, equal to 98, or less than? And I know it's greater than. And if I use a greater than symbol, then I want to think about big things, which is like obtuse. So that's what you need to be able to do for number 1 and 2 on the test. Two questions very similar to that. Your next question will be about the triangle sum theorem. And there'll be two questions based on the triangle sum theorem. The triangle sum theorem just says the three angles of a triangle always add up to 180 degrees. So if they give you a triangle and they tell you that this angle here is x plus 15, and they tell you that this angle up here is 2x plus 30, and they tell you that this angle here is just 15 degrees, well, we can use all that information to solve for x, because we're going to take all three of those things and add them together. So I'm going to put them in a nice vertical line, x plus 15, 2x plus 30, and the 15, and we're just going to add straight down. So 15 plus 30 is 45, 45 plus another 15 gives me 60, and x plus 2x plus nothing is just going to give me 3x. And we just told ourselves that if I add up all the angles of a triangle, it's got to equal 180. So I just set that, that expression equal to 180. And so now I'll solve. I'll subtract 60 from here, subtract 60 from here. These will cancel. And I'll get 3x is left on the left side. 180 minus 60 is 120. And when I divide those by 3, my 3's will cancel. And I get x equals 12 divided by 3 is 4. So 120 divided by 3 is 40. And that's what x equals. It could ask me to go back and plug it in, and if it did, 40 plus 15 up here would give me, math's hard, 55. There we go. Over here, I already knew that was 15. And since I know that stuff, I can plug in up here. 80, 2 times 40 is 80. 80 plus 30 is 110. And you could double check. 110 plus 55 is going to give me 165, and 165 plus 15 is, in fact, 180. Next up, we have the triangle inequality theorem. And there will be two questions on the triangle inequality theorem. And the triangle inequality theorem just states that there's a special relationship between the sides of a triangle and how they relate to the third side. And that's just that if you add any two sides of a triangle together, it always has to be bigger than the third side. So one of your questions is going to be just this. Is this a triangle? Or can this be a triangle? Can a triangle with sides 3, 5, and 10 exist? So I told you to take the two smallest sides and add them together and see what happens. So if I take 3 and 5 and add them together, I get 8. Is 8 greater than 10? If the answer is no, then this is not a triangle. It cannot be equal. It cannot be greater. For example, had this been 5, 5, and 10. 5 plus 5 gives me 10. Is 10 greater than 10? No, it's the same as 10. So still not a triangle. The only way it can be a triangle is if it was like 5 and 6, because that makes 11. And 11 is greater than 10. It has to be yes, it's greater, or else it's not a triangle. The other triangle inequality question will be something like this. If I give you sides 6 and 9 and tell you that we don't know the other side, well, what range could this other side be? We could replace this other side with x, which makes more sense, actually. What is the only possible numbers that could be that? And so what we did is we set up a little inequality, a compound inequality. So we put x in between two signs. We say x has to be greater than this number, but x has to be smaller than this number. And to get this number, well, we just take the two numbers we knew and subtract them. 9 minus 6 gives me 3. So x has to be greater than 3. And then I would go over here and I say, well, let's take these two numbers and add them together. 6 plus 9 gives me 15. Well, x cannot be bigger than 15. So x is somewhere between 3 and 15. That's all we can get from here, and that's all you need to be able to do.